Hello, we're continuing our study of mechanical motion, and today we're going to talk to you about the equation of this motion. What does this equation represent? Let's look at the example of the motion of a certain body, what parameters of motion we can calculate, and what the equation of such motion will tell us in general. For example, we can consider the movement of a certain object when it passes a certain path in a certain time t. That is, there is a certain path s and there is a certain time t. It is clear that in this case we will define the speed of this motion as the ratio of this path to the time spent. Then we will define the traveled path as the speed multiplied by the time of this motion. But this data is not quite enough to show where the body ended up, and this is a very important point, because when we talk about the main task of mechanics, of course we mean the ability to correctly find the position of the body at any given time. That is, how long it has passed, this is one task, but where it ended up is another task. Therefore, in order to describe such a movement, we will introduce a certain value. Let this value be called the x-coordinate, for example, if this movement occurs along the x-coordinate axis. And then, in order to show where the body turned out to be from where it began to move, we will introduce concepts such as the initial coordinate of the body and the final coordinate of the body. For example, here we have the beginning of the report, then the initial coordinate of the body. We show it by the point psi, x initial, and respectively the final coordinate of the body xf, x final, and then in this way we can show that the final coordinate of the body will be equal to the sum of the initial coordinates. So it's the initial distance from 0 from the beginning of the report plus the displacement made by this body plus s. So instead of s, we substitute this value. Thus, we are obtaining the equation of motion for a given body. And in this case, this motion is called uniform. That is, the velocity of this body is a constant value. I will say it again, depending on where the body is moving, the speed sign may change. That is, it can be either with a positive sign or with a negative sign. It all depends on the direction of movement relative to the x-axis. With the help of this equation, we can already calculate the position of the body at any moment of time. In this equation, we can supply different values of time and calculate the position of this point. So let's take an example of a body and see how this equation works. Equation. For example, the position of a body is described by the equation 2 plus. This is how we record it in writing then. What information can we derive from the numbers in this equation? The numbers tell us that the constant term in this equation represents the initial position of the object. Therefore, we can conclude that the initial position of the body is equal to the constant term. The initial coordinate of this body is 2 meters. Moreover, paying attention to the fact that by default, all values inside this equation will be measured in the C system. It is necessary to pay attention to this. And the coefficient that stands in front of time is nothing but speed. We see that in our equation it stands right here. Therefore, the velocity of this body will be equal to 5 meters per second. The plus sign shows that the body in this case is moving along the x-axis and the coordinate of the body will increase with time. For example, we need to determine where the body was after 2 seconds. Then we substitute 2 seconds into our equation. Here we get 10 plus 2, 12 meters. So we can describe this motion in terms of the equation. And of course, since we're talking about some kind of time dependence of the coordinate, we can also show that on a graph. So the graphical dependence of the coordinate of the body When an object moves in a straight line, it will appear as a straight line on a graph. This means that there is an initial point at a specific coordinate xi. As time passes, the coordinate will increase. Let's assume that at some point in time t, the final coordinate value is reached. This progression can be observed on a graph in which time is plotted on the x-axis and the coordinate is plotted on the y-axis. In the same way, we can show the velocity of this body by the angle of inclination, i.e. compare different graphs with each other. And further, we can use the graph to find the position of the body at any moment of time. That is, we can solve this type of problem in two ways. Either we substitute time into the equation of motion and find the coordinate through this equation. Or we can use the graph to find the coordinate of this body at any moment of time. Let's say, at this moment of time, we are interested in finding the coordinate of this body. The graph that corresponds to it essentially means that there are two ways to solve these types of problems. This also allows us to immediately understand how these methods will work in practice. That concludes our lesson. Thank you and goodbye.